Hello, معاكم Mrs. نشوى عادل. Today, inshallah, I'm going to explain in more details distance time graphs and speed time graphs. Let's start. At the beginning, you must know that we always place the time on the x-axis. دايما بيكون time placed on the x-axis. Okay, and here's the displacement. So here we study the change in displacement as time increases. Look at the green line. You will see that the distance increasing uniformly. This represents a steady speed or constant speed or uniform speed. They all have the same meaning. Okay? Here, look at this part of the blue line. Also, it is a straight line, like the green one. It also represents a steady speed. But what's the difference between the green one and the blue one? The green one has higher speed, but the blue one has lower speed. Why? Because the gradient of the green one higher than the gradient of blue one. Okay? Again, look at this part of the blue line. This part. At time 6, or at time here, this time here is 5. At time 5, the object is placed at point 40. At time 6, the object stays at the point 40. At time 8, the object stays at the point 40. So here the object is stationary. So this part represents a stationary object. Okay? After that, the object starts to return back from the point 14 here, moves down here to the point 0. So here it is also a steady speed while in the opposite direction. Okay, so we finished now the green one and the blue one. The green one is a steady speed, and the blue, this part of blue one speed, this part of blue one is a steady speed but less speed than the green. Here part 2, body at rest or stationary object, and part 3, steady speed in the opposite direction. Okay, or returns back to the initial position. What about the red curve? The red curve here, this is the acceleration. Okay, so here you see the acceleration. This is the shape of the positive acceleration. If the curve takes this shape like this is positive acceleration, like this part. This part, this is positive acceleration. Okay, and then from here to here, we can see that it is like a straight line, and from this point to the end here, this is deceleration. So the shape of the curve of deceleration like this. Okay, so we have like this one. It is positive acceleration. We can draw them separately like this. Here is time. Negative acceleration. Distance increasing in small rate like this. While positive acceleration, the curve takes shape like this. Or like this. Okay, so this is deceleration. And these are acceleration. Okay, so in distance time graph, we can represent a stationary object like part 2. We can represent steady speed object like part 1 or the green line. We can represent acceleration, the positive acceleration, the curve takes this shape, and the negative acceleration, the curve takes this shape. Okay, this is about distance time graph. Now what about the speed time graph? Here is the speed time graph. So here we always discuss the change of the speed as time increases. Okay, so here at time 0, the speed is, let's see here, 6, 7, 8. The speed is 8 meters per second. At time 2, still 8. At time 4, still 8 times 6, it's still 8 meter per second. So in part A, the speed is constant or steady speed. So steady speed. Okay, part B. Okay, the speed starts to decrease. So this is deceleration. Okay, bar C, speed reaches to 0 here and then start to increase once more. So here bar C is accelerated motion, or here you can find acceleration. Okay, bar D the same like A, it is constant speed. Okay, and part E, this curved part, it is acceleration but non-uniform acceleration. So part E is non-uniform acceleration. Okay, and here in B and C, your deceleration and acceleration are uniform here. Your uniform deceleration, and here also uniform acceleration. Here I want to show something which is very, very important to answer questions. Here in speed time graph, we can calculate the distance. Okay, so the distance covered can be calculated only from speed time graph. Don't forget, we can calculate it by calculating the area under the graph. Okay, so the distance, it's area under graph. So let's suppose we need to calculate the distance at the first 10 seconds. So distance at first 10 seconds. So we here from 0 to this point and to set. So we need to calculate the area under this line, all this area. We need to calculate all this area. So here we compare here to draw a line like this here, like this one, and calculate the area of this triangle plus the area of this rectangle. Here we calculate the distance to be length by width of the area of your area of rectangle plus area of triangle. So here length by width plus area of triangle is half times base times height. So here length by width, here we can consider the length from 0 as the length here we can consider from 0 to 10 times width is from 0 to 8 plus half times base from 6 to 10, so the base is 4, and the height from 0 to 8. Okay, so then we can get this is 80 plus 2 times 8 plus 16. So the answer should be 96 meters. Now I have a question. This question, the diagram, the diagram shows the speed time graph for a car traveling between two sets of traffic lights. As you see, for the last 5 seconds of the journey, to calculate the average speed of the car below. Calculate the average speed of the car between the two sets of traffic lights. Thank you for watching my video. Don't forget to leave the answer in the comments. alaikum, معكم Mrs. Nashwa Adil. Today I'm going to start with your revision for OL level. We start from chapter 2, the motion. Okay, so here the motion means